Welcome to lecture 10. We are studying basic electrical engineering and today we'll start studying loop analysis. Loop analysis is a sister technique of nodal analysis. We have studied nodal analysis and solved a couple of examples and have grasped certain concepts like supernode, etc. In loop analysis, to perform loop analysis of a circuit, we have to go through certain steps like we did for nodal analysis. The first step is that given a circuit, we have to find independent loops. The loops that, and each loop is assumed to have a current that is independent of the currents in other loops. And then we'll write KVL. KVL stands for Kirchhoff's voltage law. Kirchhoff's voltage law equation for each loop. And like we assumed in nodal analysis that the node we are writing equation for has the highest voltage. Similarly, we'll assume that the current of the node for which current of the loop for which we are writing equation is highest in the magnitude. This is an equivalent assumption as we did for nodal analysis. Here we will assume that the loop for which we are writing the KVL equation has the highest current I. Now let's solve an example and write KVL equations. We have a two loop circuit having resistors and two voltage sources in each loop, one voltage source in each loop. Right. Let's assume currents for these two loops. Since there are two independent loops, we'll assume two currents for these two loops and call them I1 and I2. By the way, we can assume any direction, either clockwise or anti-clockwise for the currents, because right now we don't know their actual direction. So for simplicity, we assume both currents to be clockwise. Right. Now first consider loop number 1 and let's write an equation for this loop 1. Right. In loop 1 we have current I1 flowing. This I1 current enters through the negative end of this 12 volt battery. There is a voltage rise. We have already studied, so it will write it minus 12. Plus this I1 flows through 6K and according to Ohm's law it creates a voltage drop across it which is 6K times I1, and then it flows through this 6K resistor, the other 6K resistor. Through this 6K resistor we have two currents, I1 current going downwards, I2 going upwards. But since we are in loop number 1, we'll assume I1 to be the higher, so we'll write I1 minus I2 is equal to 0 instead of I2 minus I1, because we are in loop number 1 and we have assumed its current to be the highest. Right, so we have written the first equation. We can rearrange terms. The terms, I1 terms can be combined together, I2 term, there is only one I2 term, and the constant term. So let's rewrite these terms so that we compile, we gather I1 terms together, 6K I1 plus 6K I1. So this is 12K I1 minus 6K I2 is equal to this minus 12 taken on the other side becomes plus 12. This is our equation number 1 taken from loop number 1. Loop number 2. For loop number 2 we have assumed a current I2 flowing clockwise. This I2 current flows through this 6K resistor, but through this 6K resistor we have another current I1 flowing downwards. So since we are in loop number 2, I2 must be assumed to be the highest. We'll write 6K I2 minus I1 plus 3K I2. There is only one current flowing through 3K, therefore 3K I2 plus 3 is equal to 0. This is equation number 2. We can collect similar terms together. Minus 6k I1 plus 6k I2 plus 9k I2. This 6k I2 plus 3k I2 is equal to minus 3. So this is how we can write equation number 2. Now we have two equations and two variables. We can solve them simultaneously to find I1 and I2. Solve them simultaneously. 6k, equation number 1, 12k I1 minus 6k I2 is equal to 12. This equation number 2, if you multiply it with a minus 2, this becomes minus 12k I1 plus 18k I2 is equal to minus 6. So this term cancel. This becomes 12k I2 is equal to 6. So I2 is 1 by 2 milliamperes. This I2 can be put in any of the two equations, either in equation 1 or 2, to find the value of I1. Let's put it here. So it becomes 12k I1 minus 6k I2 is 12 milli is equal to 12. And then these two 3s are 6. 12k I1 minus 3 is equal to 12. So I1 is 15 over 12. 3 5s are 15, 3 4s are 12. So I1 is 5 by 4 milliamperes. So this is how we have written equations for loop number 1 and loop number 2 using loop analysis and found out I1 and I2. We'll solve further problems related to loop analysis and further concepts in our next lectures. Thank you.